This is Sharma solution, class 12th. Chapter 9, continuity MCQ multiple choice question we are taking. So this question, let me just write those things just to recall you. That limit extends to a fx. If it is equal to fa, then we say that this at point x equals a, or at x which is equal to a, in this case it is 0, f0. So this is continuous. So this is equal to k. In this question it is given. This whole scenario is, because it is continuous at x equals to 0, x is tending to a. So what we'll do is, we essentially have to find out the limit of the first function. Because this is equal to f0, f0 is k here. So we will find out the limit. And this is basically not a continuity question, it is basically finding the limit question. So we'll take the numerator first. 36 raised x minus 9 raised x minus 4 raised x plus 1. This is the numerator. And I'm just indicating it with n. Denominator I'll take later. How to do this? 36 raised x is, 36 can be written as 9 4s or 36, 9 4. And to the power x, which is 9 raised x dot 4 raised x 4 to the power x. Just put it here, 9x into 4 raised x minus 9 raised x minus 4 raised x plus 1. So 9 raised x you can take common, 4 raised x minus 1, and here minus 1 common, 4 raised x minus 1. So 9 raised x minus 1, 4 raised x minus 1. Okay. Now let me tell you the formula or a relationship, that is limit x tends to 0, a raised x minus 1 by x, and this is equal to log base e a. So log base e, we generally write this as ln. Log base is ln, so ln a. So just divide it both by x and x. So since we have divided by ourselves, we have to multiply by x also. And now apply the limit. So limit extends to 0 here. Here also limit extends to 0. So this first one will be what? A raised x minus 1 by x. It will be log 9. So as I said, log can be written as ln. So ln 9 multiplied by ln, that is log base e, is 4. Now 9 can be written as 3 squared. 4 can be written as 2 squared, and in log the power comes outside. So 2 ln 3, and here 2 ln 2. Okay, 2 to the 4 here, 4 ln 2 ln 3. So log 2 log 3 we can write. So log 2 log 3 we have come across one of the option which is matching with it. This is the numerator. Okay, 4 log 2 log 3. And since we have this x square also we have initially introduced, so it's 4x square log 2 log 3. Now coming to the denominator, this numerator we have already done. Denominator is root 2 minus under root 1 plus cos x. Okay, so root 2 1 plus cos x can be written as 2 cos square x by 2. So when you take the root of this, it will be under root 2 cos square x by 2. So it can be written as under root 2 multiplied by under root cos square x by 2. So under root 2 into cos x by 2 it is. So root 2 you can take common, 1 minus cos x by 2 it will be. Okay. 1 minus cos 2 theta is 2 sin square theta. That is, wherever you have this theta, you can just make it half and keep it with sine. So 2 sine square, since it is already x by 2, we have to divide it by 2. So x by 2 is 4. So this is sine x by 4. So you need to introduce sine x by 4 in the denominator also. So let us introduce the x by 4 whole squared here. So you have to multiply x by 4 whole squared. So this whole term is simply sin x by 4 divided by x by 4, and it will be square. But it is limit extends to 0. So sine theta by theta, limit theta tends to 0 is 1. We know already that. In the previous question already we have seen. So this is going to be 1. So what is remaining? It's 2 root 2. And this is x squared by 4 4s are 16. So you can cut it like this. 2 8s are 16. X square 2 root 2 x square by 8. Now remember, this was the denominator. What was the numerator? It was 4x square log 2 log 3. Now you can cancel this x square, and 8 you have to take it in the numerator. So it goes up. It is 8 into 4 basically. So 8 4s are 32 it is. So 32 log 2 log 3 and divided by root 2. So multiply numerator denominator by root 2 just to eliminate root 2 from the denominator. So root 2 will give you 2 and 2 32, so it will be 16. This is 2 16. So 16 root 2 log 3. So now the first option is exactly matching with it, and that is going to be your answer. Okay, and let me tell you, it is third option, ln. Okay, not the first option, third option. Okay, now question number 5. So fx is continuous for all x, and we have the point of contention as x equals 0, x is equal to 1, x. For that, in this type of question, we have to really understand the concept of modulus. So this is a number line, and there are 2 points, 0 and 1. So x is 0 and 1. If it is not equal to 0 and 1, it will be this, x square minus x by x square minus x with modulus. And when x is equal to 1 exactly, we have to take fx as 1. When it is 1, when x is 1, we have to take it as negative 1. So fx is equal to negative 1. Okay. So main thing is this one, mod x square minus x by x square minus x. So what do you get here? And this, there are various boundaries, minus infinity to 0, 0 to 1 and 1 to plus infinity. So fx will make it 1 by 1, because at 0 and 1 the values are 1 and minus 1. But when it is 0 and when it is not equal to 0 and 1, we have so when it is not equal to 0 to 1, we have to take the boundaries. So this is mod x square minus x by x square minus x. So you can always write this x square minus x as x into x minus 1. Denominator also you can write x square minus x as x into x minus 1. But modulus is in the numerator. So you can separate the modulus also. This can be written as mod x multiplied by mod x minus 1 divided by x into x minus 1. Okay. So mod, you have to really concentrate on the modulus. When x is greater than 1, when x is greater than 1, mod x, for mod x simply, when x is greater than 0, it is going to be x. When x is less than or equal to 0, it will be negative x. Right? We have to just replace this value depending upon whether x is less than 0 or greater than 0. But x minus 1 is also there. So when we are above x equals 1, x is positive and x minus 1 will be positive. Because as x is dividing negative positive at 0, x minus is dividing negative and positive at x equals 1. So both are 1. Means both are non-negative, that is positive. So this both cancels and it will give you 1. Now second thing is x is less than 0. So when x is less than 0, it will be negative. And x minus 1 again, mod x minus 1 is when you have less than minus 1. Well, less than 1, it will also be negative. Okay, when it is less than 1, it will be negative x minus 1. We are talking about x less than 0. So negative x will give you negative, x minus 1 will also give you negative. For example, I am just taking a value, say negative 1. So it will be negative 2. Minus 1 is negative 2. So minus x and minus x minus 1, if you remove the modulus, denominator you have x and x minus 1, you can cancel these. Minus is plus. So if x is less than 0, then you get both numerator denominator as equal, negative negative cancels out. So this is also 1. I hope you got the idea. This is the whole crux of this question. Now let us see what is between 0 and 1. If it is between 0 and 1, so the x will give you positive when you remove the modulus, and x minus 1 will be negative. Why it is negative? Because x at 1, it decides for x minus 1 whether it is positive or negative. So this is the boundary of x. Right side it is positive, left hand side is negative. But x, when it is greater than 0, it is going to give you positive value. So x and minus x minus 1 will be there. Denominator you have x into x minus 1. So you can just cancel this, you will get negative 1. So negative 1, you have x between 0 and 1. And this, please remember, so we are talking about x equals to 0, which is already given in the question. X equals 1 is also given in the question. So there are multiple boundaries, multiple points. So we will try to combine all these. What is happening in these boundaries? Because they are separate values, some values are given. So we can just replace this equality sign and take it with the less than or equal to sign. So x is greater than 1, x equals 1, both are different, so we cannot combine them. X is less than 0, x is between 0 and 1, and x is less than 0, it is 1 minus 1. So x is less than 0, it is less than 0 and it is equal to 0. So both are 1. So you can combine these two. X is less than equal to 0. So I have combined less than and equal. X less than 0 and x equal to 0. You can combine these two. And since it is equal to 1, we can just write 1. How about 0 and 1? Between 0 and 1? So you are getting minus 1. So you can combine that x between 0 and 1 inclusive. So final fx is like this. 1, if you go up 1, you get 1. X is less than or equal to 0, you get 1. And between 0 and 1, where 1 is inclusive, is negative 1. I hope you got the idea. Now this is quite easy. You don't have to go for left hand limit and right hand limit, because it is picture clear that whether it will be continuous at point or not. So now we'll actually check 0 and 1. 0 and 1 point we are going to check actually. How? Just see. So if you have 0 and less than, you add 0. If it is less than 0 or equal, it is 1. But when you just move ahead of 0, above 0, it is negative 1. So at x, you can say that at 0 you can take 0 minus or 0 plus, that is left hand limit, right hand limit. But we see here that at left side it will be 1, on the right hand side it will be negative 1. So the left hand limit and right hand limit will not match. Okay, in proper continuity scenario, you have to write limit fx, x tends to 0 minus, then you will get a 1. When you apply limit x tends to 0 plus fx, it is going to be negative 1. But they both are not equal. That means when they are not equal, that means the function is not continuous at this point. At 0, it is not. Again, at 1 will do the same thing. So 0, it is not because it is not matching. Let us see the 1. At 1, that is x greater than or it is 1, it is 1, and x less than or equal to 1, it is going to be negative 1. So when you check limit x tends to 1 plus and x tends to 1 minus, both are not same. Okay, they both are 1 and minus 1, they are not equal from this final combination I made. Or you can write the limit also, just like 0. So 1 is 1, 1 is minus 1. So it is not continuous at 0 or 1. So you can just write this answer. Remember previous question we just talked about? It is not the option first, it is ln option. So both 1 and 0 you have to write, and this is how you have to do it, because this left hand limit, right hand limit, I already showed you. 1 minus h, 1 plus h you have to write, 0 minus h, 0 plus h you have to write, and just because these are constant values, constant will come, right? Now this question x, the point is pi by 2. When the f a, which is f pi by 2, is equal to k, and we know that when we have f pi by 2 or f a, and this is given as k, and this is equal to nothing but limit x tends to pi by 2, and then this x tends to pi by 2, we have to take this all function, right? Let us write it as fx. So we have to find out the limit of this function at pi by 2, and we just have to equate it with k. The value of the limit will be equal to k. I hope you got the idea. In totality, the question will be solved by finding out the limit of this function at x equals pi by 2. So this is the solution just for your reference. If you are able to solve yourself, then it is okay. But we are going to do it by ourselves. We will take one by one term. Every term I am going to take separately, because it will take, this is always a good idea not to combine all of these, because there will be some confusion. So in left hand limit, right hand limit, what do we do? Pi by 2 minus h and pi by 2 plus h. Since it is already given in the question, it is continuous at x equals pi by 2. So left hand limit and right hand limit will be equal. So either you can try with pi by 2 plus h or pi by 2 minus h. I am doing with pi by 2 minus h. Okay. So the limit, every time I am going to apply this limit, h tends to 0 because x is tending to pi by 2 minus h. 1 minus sin x will start with the first term. 1 minus sin x is what? We have to replace first x by pi by 2 minus h in each and every question. So 1 minus this x is replaced by pi by 2 minus h. So sin pi by 2 minus h, and sin 90 minus theta is cos theta. So it will be 1 minus cos x. Okay. Now 1 minus cos x can be written as 2 sin square. It is h actually. 2 sin square h by 2. Do 2 sin square h by 2. H by 2 is with h. So 2 sin square h by 2. So we have to introduce h by 2 whole square, that is h square by 4, in the denominator and numerator. Why we are doing this? Because we know sin theta by theta, limit theta tends to 0 is equal to 1. So it will be 2 sin h by 2 by h by 2 whole square. So let me remind you again. Limit theta tends to 0, sin theta by theta is 1. This is all going to be 1 and multiplied by h square by 4. So 2 into h square by 4. 2 gets cancelled. You get h square by 2. So please remember what all terms are giving you. The first term is giving you h square by 2. Now coming to the second point, which is pi minus 2x whole square. Pi minus twice of x whole square. So we have to replace this x by pi by 2 minus h. So pi minus 2 into pi by 2 minus h. And we'll square it later. Let us solve it. Pi minus 2 into pi by 2 and plus 2, that is 2h. This 2 gets cancelled. Pi minus pi is 0. So only 2h remains. So it will be 4h square because it is square. First term gave you h square by 2. The denominator gave you 4h square. So let us solve it here also, or you can take all other two terms. So the first term is h square by 2 and denominator you have 4h square. H square gets cancelled. You get 1 by 8. So the first term is giving you 1 by 8. We'll use it later. Coming to the third term, which is log sin x. Let me just change the color so that you understand. We are taking each term separately. Now I am taking log sin x. So sin x will deal with sin x. Sin this, you have to write pi by 2 minus h in place of x. Sin pi by 2 minus h. So it is cos h. Sin 90 minus theta is cos theta. So cos h is under root 1 minus sin square h. Because sin square theta plus cos theta is 1. Cos h you can write it as under root 1 minus sin square h. Okay, now log. So there will be log 1 minus sin square h, and this can be written as under root is simply power raised to half, and in log always half the power comes outside. So half log 1 minus sin square h. So there are certain questions which have the same formula being used, because log 1 plus x by x, limit x tends to 0 is equal to 1. So we have log 1 minus sin square h, so you need a negative sin square h in the denominator. So when you are including, because you can write it as 1 plus minus sin square h divided by minus sin square h, so that it matches the formula. So why we have this minus sin square h in the denominator, you have to have negative sin square h in the numerator also. So this whole is limit h tends to 0. When you apply, it is going to be 1. So you are left with half into negative sin square h. This is what log sin x has given you. Coming to the last term, which is log 1 plus pi square minus 4 pi x plus 4x square. So let me change the color so that you understand this is the fourth term we are dealing with. So log, I'm not writing log, I'll just write log later. It is 1 plus pi square minus 4 pi x plus 4x square. Okay. Now 1 plus pi square minus 4 pi, in place of x write pi by 2 minus x, plus 4x square, in place of x write pi by 2 minus x whole square. H, it is pi by 2 minus h. So 1 plus pi square minus 4 pi into pi by 2, and minus minus become plus 4 pi h. Okay, here it will be 4. Now open this, a minus b whole square. So pi by 2 whole square, pi square by 4 plus h square minus 2 into pi by 2 into h. 2 into pi by 2 into h, 2 gets cancelled, you get pi h. Now this 1 plus pi square, 2 gets cancelled, so you have minus 2 pi square. Minus 2 pi square plus 4 pi h, and just multiply this, 4 gets cancelled, pi square plus 4h square minus 4 pi h. Now this gets cancelled. A pi square plus pi square is 2 pi square, minus 2 pi square is there, so these all pi square gets cancelled. So you are left with 1 plus 4h square. Please remember, it is inside the log. So log 1 plus 4h square. So again, log 1 plus by x, 1 plus x by x. So you can include, they introduce 4h square in the denominator, so you have to have a 4h square in the numerator also. So limit h tends to 0, this whole is going to give you 1. And you have 4h square here. Now minus half sin square h. Okay, now let us take the all terms. So minus half log sin h gave you minus half sin square h. And in the denominator you have 4h square. 4h square. Okay. So this 4h square, you can sin h by h whole square it is. And you know that sin theta by theta, limit theta tends to 0 is 1. So minus 1 by 8 will remain. And remember, this is the second term. Now remember, you had already 1 by 8 for the first two terms. So 1 by 8 into minus 1 by 8 is going to be minus 1 by 64. So this is equal to k. K is negative 1 by 64. That is the answer of this question. Okay, this question will take later. Thank you so much. Take care of yourself.